Hello and welcome to our presentation. MVPDs and cable operators have been sharing broadcast signals for many years. Within the next few years, however, the signals broadcasters share will be quite different. A transition to a new broadcast television standard, ATSC 3.0, has started rolling out at TV stations across the country. This presentation is designed to help cable system operators understand how these signals are different than the ATSC 3, ATS1.0 signals you have passed for the past decade, and how to ingest and use them. We have two experts to help us along. Perry Priestley is COO and CSO of Broadcast Electronics, Elenos Group, and Joonyoung Park is VP and Fellow at DigiCAP. Let's get started.
Thank you, Josh. Thank you, Joonyoung. This is Perry Priestley speaking. I thought I'd just summarize what Joonyoung and myself will be talking about over the next 20 to 25 minutes. First, we'll cover who and what is the ATSC. What does the ATSC 3 system offer to the broadcaster and to the actual viewer? Then we'll do some comparisons between ATSC 3 and ATSC, and also what is the transition and timing and the methodology for the actual transition from ATSC to ATSC 3.0. What will be different for cable companies, and then Joonyoung will look at specifically a new receiver decoder, go into a fairly detailed description of what's available, and then we'll finish off with a sort of a brief summary of a recap of the actual presentation. Next slide. So, first of all, many of you may be thinking who or what is the ATSC? Well, the ATSC is a group of broadcasters, actually representatives from broadcasters, manufacturers, and tech companies. It's anybody really interested in to have a seat at the future technology table. It was established about 25 years ago to create HDTV, high definition television, and that was actually officially labeled ATSC. So why ATSC 3.0 and not ATSC 2.0? Well, not to put too many puns on this, but ATSC 2.0 was too little too late. ATSC 2.0 was developed as a backward compatible system to ATSC 1, but it didn't have sufficient advantages to the broadcaster, and it had way too many compromises to be of interest. So it was decided to scrap ATSC 2 and move straight to an entire new standard, ATSC 3. The big difference, of course, this one is that ATSC 3 is not backward compatible to ATSC 1, which means no existing receivers or IRDs will be able to receive, demodulate, or decode the signal, and therefore must be replaced with some kind of ATSC 3 compatible device. So the first question you may be asking, well, why bother? Why change to ATSC 3? In other words, what's in it for the broadcaster? Why is he doing this? And even more importantly, what's in it for the viewer? Why would they be interested? So let's take a look at some of the key advantages, and firstly from the viewer's point of view. From the viewer's point of view, both the video and audio quality will be significantly improved with 4K or HDR for the video, which has frame rates of potentially up to 120 frames per second. And as a comparison to the so-called high quality Blu-ray technology, this only actually has 24 frames per second. ATSC 3 will have a much higher dynamic range, which means the whites will be whiter, the reds will be redder. Pictures with both dark and light areas that often sometimes oversaturate, there'll be much less saturation and much higher definition. And the system will actually have what's called a wider color gamut. A wider color gamut means that, well, as an example, the average eye today can see 50% more color than is actually available in today's HDTV. Whereas with ATSC 3, the color system provided by ATSC 3 will provide more than double the color range that any human eye can see. So it'll be way more, there'll be more colors there than we can actually see in ourselves. For the audio, it can provide surround sound, Dolby 2.1, all the way up to Dolby 7.3. Other nice things that it will include is a far more updated and directed or focused emergency alert system, which will be a completely and better, safer system for everybody, a lot more useful. And it will also provide a better closed captioning, including American Sign Language system, and even descriptive video. Next slide. For the broadcaster, high compression rates, it's in a brand new compression system called H.265, will significantly improve the efficiency of delivering content. It'll actually have probably 8 times the quantity of programs, which could mean that up to 60 programs in a 6 megahertz TV channel can be provided. Or on the other hand, it can provide significantly improved video and audio quality, or a balance of both of those. It has standards for encryption, which is new, which allows video on demand, an entire new business for the broadcaster. It's all based on Internet Protocol, IP, which means it's compatible with other industries, unlike ATSC. It's compatible potentially with the broadband industry. It's compatible potentially with the cellular industry. And the method of modulation, and this is a big one, is now, will be the same standard that all other international digital television standards employ, OFDM. OFDM is also used by all digital radio standards. It's used by the LTE cellular phone systems. It's the same standard used with 802.11 Wi-Fi, and mostly all communication systems throughout the world. OFDM for broadcasters and customers means better reception, immunity to selective fading, resilience to interference, and simple channel equalization. That means it's going to be much better coverage and a lot easier to design receivers and easier to and lower cost transmission systems. The use of OFDM, which will be brand new to the broadcast industry, will make a tremendous difference to the coverage and the ability to reach different customers, including mobile receivers. The first time television has ever been able to attract a device that's moving, devices that could be inside cars, that could be inside trains or buses, and potentially aimed at cell phone users or tablets or the PC. Next slide. So from a technical point of view, and probably of great interest to the cable companies trying to receive these signals, there are some really key differences between ATSC1 and ATSC3. Just to give you a quick summary of some of the differences, ATSC3 has 7 different modulation schemes, whereas ATSC just had the one. 24 different forward error correction systems, again, ATSC just the one. 3 multiplexing systems, it has a guard intervals, it has fast Fourier transforms. ATSC pretty much didn't have those at all. Next slide. Looking at a comparison, ATSC, the older standard, is a single carrier system, 8 VSB, 8 decidual, so it's 8 levels of decidual sideband. It has fixed bit rates, it has fixed carrier to noise ratio of 15 dBs, reception capability, it supports SD and HD, but it has no broadband connection and no channel bonding capabilities. ATSC3, on the other hand, as I mentioned, uses OFDM as a multi-carrier system. It has variable bit rates, it has variable and adjustable carrier to noise reception ratios, and it supports not only a standard definition, high definition, but also ultra high definition, 4K, and even 8K if necessary. Because it's IP based, it also allows a merge potentially between broadband and broadcast. And because it also has the capability of channel bonding, it will allow 2 channels to join to one and get much broader bandwidth and a larger data throughput, but it also allows bonding to communication systems like cellular networks. ATSC1 uses an old-fashioned, nearly 35-year-old video compression network system called MPEG-2, whereas ATSC3 uses H.265 or HVEC. ATSC1 uses an older Dolby AC3 system, where ATSC3 uses the new Dolby AC4 and MPEG-H. Next slide. So let's talk a little bit now about the transition. So how and when will all this take place? First thing is, there's not going to be any additional channels provided by the FCC to broadcasters to make it an easy transition. And another important fact is, this is not a mandatory implementation. ATSC was mandatory. ATSC3 will not be mandatory. And so this is actually going to make it much more difficult for broadcasters to transition, and it's going to make the timing very, very important and very critical. In terms of timing, let's talk about what's going on today. There are about 12 stations on the air now, and there's actually another 6 more readying to go on the air right now as well. And planned another 44 stations in a relatively short term. I believe they're hoping to be on the air by first quarter 2021. This 66 TV stations actually represents a coverage of 75% of all US viewers. So that's a significant coverage pattern for the US. And many more stations, including low power stations, Class A and translators, will also implement ATSC3 over the next couple of years. So that's from the transmission point of view, but let's think about from the reception point of view. And nothing happens until people have receivers at home. So there are a few products out there today, but the choices are very limited. But brands like Sony, LG, and Samsung are expected to release new 4K ATSC3 products compatible with ATSC3 in both video and audio by this fall. And more manufacturers have promised to enter the market by the end of 2021. Next slide. The basic plan for full power stations, and this is only applicable to the full service TV stations, is that they will use what's called a Lighthouse Plan, which means they will change one station in a market from ATSC1 to ATSC3, and then have to have an agreement with another station in that market that retransmits their programming. As you can imagine, these are sometimes competitors in the same market, so there has to be fairly complicated and I'm sure long-winded legal agreements, as well as a lot of coordination about switching on and switching off and bandwidth sharing and bit sharing as well. So this is what we call phase 1. Today, let's just say the past, all stations were ATSC1. As we move to phase 1, one station in each market will be an ATSC3 station, and all the other stations will still be ATSC1. Next slide. Phase 2 will be just an expansion of phase 1, where more stations will carry ATSC3 and less stations will carry ATSC1, but all programs will still be duplicated. And then in the years to come, potentially 2, 3, 4, 5 years, phase 3 will happen where all stations will implement ATSC3 and ATSC1 will be shut off for good. In my opinion, this will most likely be at least 5 years. Another thing to remember, as I mentioned earlier, this transition only relates to the full service stations. Translators, low power TV stations, and Class A stations do not come into this category, and they can change to they can implement ATSC3 at any time. They do not have to carry on transmitting ATSC1, whereas the full service stations have to carry on ATSC1 for at least 5 years once they start transmitting ATSC3. Next slide. So to summarize the situation, the cable company receiving this signal will have to obtain ATSC3, have to get a new receiver that can decode and demodulate the ATSC3 standard. There will be times, and this is going to be a difficult period, when you may have to receive some signals from ATSC3 transmissions and some signals from ATSC1 to obtain all the content you need. Cable companies may have to select programs differently as well, because there could be a larger number of programs that you may have to eliminate. There could be a lot of duplication of programs which have different qualities and different formats. And there could be a lot of other items in the system that you may have to consider as well. Next slide. In addition to all these changes, just to add more complexity to the system, the emergency alert system will be an entirely different technology, as will the program guide, or as it's going to be called, electronic service guide. There will also be a lot of content that may need to be ignored, like specialized data, non-real-time data as well, that may be being delivered for overnight storage. And of course, this technology also takes into consideration applications. So there will be data as broadcast apps that could be potentially used by cable companies, or they actually could or need to be ignored in a sense. Next slide. And I think that's it for me. And it's over to you, Josh.
Thank you, Perry, for describing the differences between ATSC and ATSC 3.0. Now, Joonyoung will describe a way to receive and translate ATSC 3 signals into existing cable head-end systems.
Okay, thank you, Josh. Now, let's talk about the problem that cable operators will face, translating ATSC 3.0 signal to existing cable infrastructure and the set-top boxes today. So basically, you need to have two functions. One is the receiver, and we call it transmux function. The other one is the transcoder function. Obviously, the cable operators, if they have already transcoders, there's a way to integrate this transmux function and receiver function to the existing encoders. But for the sake of the explanations, I will explain those two things at the same time. Of course, you need to have an input, and input is pretty much traditional, meaning that you can receive the RF, the ATSC 3 and ATSC 1 signal and at the same time. And you can receive ATSC 3 or MPEG-TS over the IP. That's the interface. And the output will be also the traditional, IP or the traditional TS output. Okay, going next slide. So this one, give you, ideas of what are the complexity under the hood. Of course, in the receiver function, so there's all kind of the protocol translation from the ATSC 3.5 all the way up to the media, and then make it available through the traditional HTTP protocol, or they fit into the transcoder function. So as you can see, there's the decoders and players here, and also the audio translation, transcoding, and video transcoding, and caption transcoding. Of course, the signaling mechanism, PSIP was the traditional TS the signaling mechanism. The ATSC 3 has a different signaling mechanism. That in the metadata has to be also translated and fitted into the MPEG-2 based systems. Okay, and then if there are also, I understand that the cable operators today have a lot of advanced or the latest set-top boxes, understanding H.265 and the MPEG-dash protocols. That also can be directly fed from the transmux function. Okay, going next slide. This could be one of the equipment or appliance sitting inside a cable infrastructure. So we call it an integrated receiver device, IRD. So as I explained it, input output in the previous slide, there is the series of inputs, and then there is a series of outputs here. So basically, you need an RF function for the ATSC 3 and the 1.0 signal reception, and then Ethernet right here. And then you can plug the your connectors there, your cables there, and then also you can connect the Ethernet cables and the ASI cables for the output. So it's going to be a pretty simple device for you to operate. On top of that, you need to have some management function, as Perry explained that there are multiple programs and duplicated programs. So as you tuning into the ATSC 3 or signals, with the tuners, there should be a way to manage and control that the transmux and receiver functions to receive the right programs and right channels for your cable retransmission. So this is the working template, working user interface for the management and control function of that IRD device. So as you can see, tuners are locked down here, and you can see this in the signal ratio and the signal strength, and also you can check the bit rate you're coming in, and then you have some the interfaces to select programs and the channels for the retransmission. That's all my slide. Back to you, Josh.
Great. Well, in summary, there's some new signals headed your way that you're going to have to manage at a cable system. You're going to have to deal with some new equipment, and you're going to have to rethink your ingest procedures because ATSC 3 signals have a lot of extra information, some of which you need, some of which you don't need. So don't be caught off guard. This transition is coming to your community wherever you are in the United States. If you get in touch with your local broadcasters, they will know when they're transitioning to ATSC 3, and they can give you a timetable that you can work with them on. It does pay to plan ahead and to test signals, that's the process that most broadcasters do. Is they set up test signals first, try things out, and you can work with your local broadcasters to make sure that you have a successful transition, and decide on a strategy and plan ahead for it because it's coming. Anyway, thank you so much for attending our presentation. And thank you, Perry Priestley and Joonyoung Park, for sharing your wisdom. If anyone in the audience has a question for either of these two gentlemen, their email addresses are below, and we'd encourage you to send questions. Thank you very much.
Thank you.
Thank you.